My name is Steve Cousins. I'm at the University of Maine system. I'm currently the interim director of the Advanced Computing Group. I'll be talking about the bringing Katahdin, which is our HPC system for the system, to the masses, in which case that's the CC star part of our cluster that we use the OSG to meet the needs or meet the requirements of the CC star grant. Katahdin is the name of our largest mountain in the state. Forgive me, I'm a bit out of my element here. We named our cluster after this. It's I'll step back. I'll channel Marone a little bit and give the background of where we came from. I started in marine sciences at the University of Maine, and we were a consumer of HPC resources wherever we could find them. This was around 2000, and Maine, we were just starting to have some resources. Bruce Segee, who's professor of electrical computer engineering, got a couple of grants from the Department of Defense to set up some prototype machines for their research. And that was actually the first time and probably the only time we were on the top 500. I started working with Bruce to get access to some of the machines once they got decommissioned from that. From there, I kind of transitioned to the HPC side, working with Bruce. In 2012, we formed so that was all at the University of Maine campus, which is the, I guess I'll, sorry, University of Maine campus, which is the flagship campus of the system. In 2012, we transitioned to become part of the overall system, to provide resources to all of the campuses. Since then, we've built up the HPC system with the help of large help from the National Science Foundation for MRI grants, and then more recently CC star grants, and other grants that professors get that contribute. Currently, we have about 120 nodes. Total cluster size is around 4,000. Of that, the new CC star grant gave us about 1,500 cores, and of that, we're making about 20% of that available to OSG. So the University of Maine system, as I said, it's actually a set of 7 universities, totaling about 33,000 students. The majority of the research is actually done at what's called UMaine, which is at the Orono campus, right in the middle of the state. And similar to the Great Plains, we're spread out quite a bit, but we only have one data center in Orono for running the HPC jobs, HPC and cloud jobs. We do have a backup system in Portland at the University of Southern Maine. And as I said, we've formed in 2012. The ACG, we're here to provide help with researchers in any way we can, primarily in computing. We offer HPC, cloud computing, data storage and visualization capabilities, and through outreach, we work with grant writers to come up with data management plans, and again, any way we can as far as helping people to be successful with their grants. And we also, especially with the help of a CC Star grant, that we were able to hire a cyber infrastructure engineer. We offer research computing consulting to different groups. We're a small group, and we actually have a few positions missing right now. We're searching for. Bruce Segee stepped down. He's actually retiring pretty soon, and I've taken his role, as well as being supercomputer engineer and administrator. Currently our cyber infrastructure engineer is, we're searching for a new one, as well as data architect. Just to give an idea of some of the projects that we work with researchers on, this one has been in the news recently due to the record heat that the planet has had. And Sean Burkle of the University of Maine Climate Change Institute, who's also the state climatologist for Maine, has put together this project called the Climate Reanalyzer, where he takes data from all sorts of places, compiles it, creates planetary views of the data, and provides it to in a website. Our cyber infrastructure engineer and CC Star cyber teams projects that we've been involved with have contributed to Sean's work, although he has done the vast majority of the intellectual work by far. But a lot of students have benefited from working on that project. Another professor, similar, Sean uses both the HPC and cloud resources to do his work. Similar with Casey Lagarde, who's a professor of forestry, who put together this slide for me. He does similarly uses HPC and cloud resources to compile and estimate biomass, species, land cover of forests in Maine. He's working to expand that throughout the country as people are requesting. So those two were at the University of Maine in Orono, the Maine Research Campus. This project is at the University of Southern Maine, where they deal with health data, and Kate Ahrens does a lot of work. With this project, we set up a cloud system for working with compliant data. They were just working on their own laptops and remotely accessing compliant data through a VPN, and the performance was terrible, trying to use terabytes of data. So we set up a system for them to use, and that's been it's worked out well. It was our first instance of working with compliant data. So we worked with our security office to make sure we jumped through all the hoops for that. Had many, over the years, many collaborations, external. mentioned CC Star projects. We work with an MGHPCC, which is a consortium a data center in Massachusetts. We also ERN, which I'll mention in a minute, is a prototype. It's in the works to try. They're trying to get funded for mid-scale type application, and we've been involved with them for prototyping some of the early cluster design that they were interested in. So for the current CC Star award, we purchased roughly 1,500 cores. Common is the driver for this was high memory compute capabilities and storage. Researchers that did not have could not run in the footprint that we had previously with only maximum 256 gigabytes. So we got a number of nodes with 512 gig and 4 nodes with a terabyte memory to address these needs, along with about a petabyte of storage to add to our Ceph system. We originally were thinking, at this time of proposal, we were thinking ERN be our collaborator for, okay, thanks. The ERN would be collaborator to meet the needs for the CC Star, but so just because we've been working with them already, but the first proposal that our pre-proposal that they put together was not, it did not go past the pre-proposal, and they got planning grants, but we needed something to connect with. So we went with the OSG on the solicitation. Mentioned OSG, and I've heard of them. We've heard Condor for many years, and actually used it a long time ago. And so we decided to go with that. And we also, since we did have storage, and I'm not positive if this is a requirement of the CC Star, whether we were a CC Star compute grant, and but we did have storage involved, and I just planned on making some of that storage available to a resource as well. And since we've been involved with MGHPCC, who is a strong part of the OSN, Open Storage Network, we've worked with them to create a pool of our data, or our storage, to be part of the OSN. So we are on their map as well. And we already had our own Ceph system. OSN had basically the idea of a pod that is a kind of a single system that you can easily implement with their help. We didn't really want to set up a separate one, so we worked with them to carve out a separate pool from our existing storage and just add that in. And early on, we even they were flexible enough to use some of our ZFS storage which is, they're all object based. ZFS is, POSIX based. We put MinIO in between to create a S3 interface for the ZFS storage, and that was successful. So they were. I think they're not using that anymore because MinIO is not supported. So anyway, sorry for all that. My part of the reason for that being so long is Tim invited me to talk on this, and my first thought was, well, it's not going to be very exciting. It's basically everything worked really well. and it was a pretty easy process. So I'll talk about what we did go through and some thoughts on it. Yeah, everything from day one has been extremely positive. The only, I guess, the hesitancy, one of many things that took us a little longer to get going on this was my initial read of requirements made it seem like there were a number of things that we would need to do. For instance, have a SQUID server, caching, networking type of thing. The Network Maine, who we work with, they're part of the University of Maine system, the networking group. They have their own serving SQUID servers, and we were trying to figure out a way to leverage that. That wasn't going well. I thought that was kind of a deal breaker at first. Similar to storage and caching, I thought it was going to be a requirement that we set that up. All of this was my own, not very, I guess I just didn't have all the information. I also thought we were going to need to set up our own CE server. So we're, as I said before, we're a small group, had a number of things going on, and this made it take longer to get started. Once I got hold of Tim, though, things smoothed right out. He basically said, no, we can start without any of those things. So once we got going with that, it just happened. Yeah, as I say, we started out just OSG hosted the CE for us. Didn't require the proxy, didn't require the caching storage. You know, we realized that possibly that would mean that there would be some performance issues at times, but they assured us that they would let us know if that was a problem, and we'll go from there. Basically, all we needed to do was set up a user account, open SSH up to a certain number of machines for them to access, and away they went. So we've set that up, we early on we just had individual one core glide-ins, where so every job was a single core, and every job was basically tied to a Slurm job. So we thought to try to reduce the number of Slurm jobs and reduce some overhead. We increased the number to 12 cores per glide-in. This also allowed for some parallel capability on the, for the OS pool jobs, and we thought that would be a good thing. Being in more of an engineer type, I was interested in efficiency, how much work actually is done. You know, the glide-in might be sitting there, might not be doing anything, just waiting for jobs, or there might be overhead associated, since we didn't have any of the caching going on. How much of that is, I just wanted to get some metrics. I asked, we talked with Tim about that sort of thing, and he said he's open to working to try to get some of that and make that type of information available to everyone. So personally, I went ahead also just did some analysis using Slurm tools like the SCFF tool to, I just looked at jobs for June. On the left is the OSG metrics for our cluster are what we've made available, and it closely matches around 113,000 core hours. there, and that matches up with what we had. The looking at a single job on the top right, it showed about a 63% efficiency as far as the CPU goes, where the CPU, was only using about 63% of the time that the job had. So I checked throughout the whole month, and it turned out that's roughly about the same. So overall, about 66% efficiency. This is nothing, I don't know where the other 4% is going, whether it has to do with the caching and all that sort of job setup overhead and things like that. That's something I'd like to look into, but it's not, possibly not network necessary. It's just information at this point. It's not saying anything is wrong. It's just maybe room for improvement. And similar with memory allocation, we might be able to take a look at that as well. Yeah, so our cluster might be a little different than others. Periodically we have times when we have a lot of jobs that are waiting. Sometimes we don't have any jobs waiting, and only 50% of the cluster is being used. So it seemed like a good OSG pool, OS pool. We could go greater than the 20% if we have preemption in place, where we could say we want to give the OS pool 50% of our cluster, but if one of our local jobs wants to start running, then it stops it, and then it kind of gives us all the best of both worlds. Our cluster gets better utilization, OS pool gets more capacity as well. I understand that probably not everybody's in this situation, and we might not even always be in this situation. So we need to keep an eye on this. I have set a preemption. I worked with Tim quite a bit, and Tim and Jeff, and set that up. It wasn't exactly as easy to find the information that I needed. Currently, we set these parameters in Slurm, and it seems to be working. The only thing that is not working is the preempt exempt time, which is what we, amount of time after a new job says you got to stop, that the OS pool job can continue, just to be nice, to give it a little bit more time. So anyway, takeaways. I highly recommend anybody who has any thoughts of sharing resources with OS pool or OSG in general, to do so. It's been a great experience, and I think there's a lot of value for it for researchers and the institution themselves. For me, I'm planning on going back and, with things that I've learned so far, be an advocate for the OS pool, and try to get our resources to our researchers to use these resources. And talk previously was, how can we expand, let more people know. And I just last night I thought possibly Campus Champions, something like that. Talked to Maron a little bit today, and he likes the term campus facilitators, I guess, better, and I think that's appropriate. Thank you, Tim, for all your work. Jeff, thank you, and everybody at OSG, and thank you, Kevin, as well, for all our support for Maine CC Star grants. We've I think our researchers are getting a lot of value out of it. Thank you.